Hello. Today we're looking at an application question for factoring. So it involved rectangles, and let's see how it works. The question number 5a says, given the diagram below, polynomial 6x squared minus x minus 1 represents the area of the rectangle ACDE. Now that is basically the total rectangle in the picture. You're given two dimensions that are also repeated on the side here, is that BC and FE are both equal to 3 units. Well, the unit is on factoring, and let's start off with the 6x squared minus 1, minus x minus 1, and make sure that we can factor this. This is a complex trinomial if you look at the leading coefficient as being 6. You could actually do this like a simple trinomial because the last term is simply a 1. But we'll go through the usual routine. I'm going to look at the factors of 6, which are 1 and 6, 6 and 1, and on the other side, 1 and 1. Now, sorry, I forgot the 3 too. 1 and 6, 3 and 2, 2 and 3. Now, you don't actually have to put these guys backwards because the 1, 1 backwards is the same thing. I'm looking for the pair of factors that's going to subtract to give a 1. I don't care about the sign on that right now. So the two values I'm going to look at are the 2, 1 multiplied together, which is 2, and then 3 and 1 multiplied together, which is 3. So in other words, my first row is going to be the 2, 1, and the second row is going to be the 3, 1, second bracket. So I take this, set it up, and I'm going to have 2 and 1 and 3 and 1. Remember, the first row goes into one bracket together. And they're both going to have x's on them. Now, the tricky part about the complex trinomial is that when we have a negative on that final term, it means that the signs are either going to be plus minus or minus plus. And so it's up to us to figure out which one is going to give the negative 1 as my product of the inner and outer numbers. Well, the 3x on the inside is going to have to be negative, and the 2x on the outside, multiplication, is going to have to be positive. So the negative is going to go on my first bracket, and the positive is going to go on the second bracket. So the area of the entire rectangle, ACDE, is 2x minus 1, 3x plus 1. Now, when I make up these questions, I have to make sure that it doesn't matter if you choose the larger or smaller one when it comes down to labeling the diagram. But there is this tendency to recognize that 3x plus 1 is going to be bigger than 2x minus 1. So I'm going to put the 2x minus 1 on the length of the side CD, which looks a little bit shorter. And I'm going to put the 3x plus 1 along the bottom for ED. Notice, by the way, AC is also 3x plus 1. So when I'm trying to determine the distance between A and B, I know that adding 3 plus that distance has to give me 3x plus 1. Now this may confuse some of you guys because to find out the distance from A to B, I got to do 3x plus 1 minus 3. 3x plus 1 is the entire length minus 3, which is the shorter part, which is going to give me 3x minus 2 as the distance or the length of AB. In the same way, on the length of AE, I know that 2x minus 1 along this side sorry, is the full length, and I got to find the portion that goes from A to F. And just like before, it's going to be 2x minus 1, and I got to subtract that 3, which is going to give me 2x minus 4 for that length AF. Hope the sideways is not bothering you too much. It's kind of weird. I just went ahead to find out those lengths without looking at what the next portion of the question asks. It says, what is the polynomial that represents the area of rectangle ABGF? Well, ABGF is this shaded area right here. And the dimensions, length and width, are going to be 3x minus 2, just like on the top, and 2x minus 4, just like on the left side. And it asks for a polynomial, therefore you have to work it out. So it's going to be 3x minus 2 times 2x minus 4. Now the order of these brackets doesn't matter because of commutative property. And so you multiply it out to get a polynomial. This is a product of two binomials. The polynomial is going to be 3x times 2x, which is 6x squared, minus the 12x, minus the 4x, plus the 8, which simplifies, sorry for using up the last little section on the page here, 6x squared minus 16x plus 8. Now, question's going to come to mind. Hey, am I supposed to factor it out? No, don't factor it out. It's asking for the polynomial, which means it's not asking for the factored binomials. I got one other question I'm going to do, and that's at the bottom of page 33, checking out similar kind of situation, sorry, the bottom of page 32, similar kind of situation with a rectangle. It asks you to show that the area of the region that's shaded is equal to 3 bracket x plus 12, x minus 8. And I'm giving you that the area of the entire rectangle, ABCD, is this trinomial. This question looks a little more difficult than it really is, because at the beginning, you have to remember that the area of the shaded is going to be equal to the area of the large minus the area of the big minus the area of the small. And it's kind of a gift because the area of the big is already given as a expanded polynomial. And the area of the small is going to be the product of x plus 3 and x plus 3. Now, you should know this well enough. You can work it out on the side, but x plus 3 times x plus 3, if you have to FOIL it out, is going to be x squared plus 6x, right? Because 3x plus 3x plus 9, right? There is the outside product, which is 3x, and the inside product, which is 3x. So I'm going to write that down in a bracket here, x squared plus 6x plus 9. And simplify this. Remember that that minus is going to affect all three terms in the bracket. 4x squared plus 18x minus 279 minus x squared minus 6x minus 9. A lot of like terms here. 4x squared minus x squared is 3x squared. 18x minus 6x is going to be 12x. And negative 279 and negative 9, right, we change to a negative, is going to be negative 288. Okay. And what did it say? We have to show that this is equal to that. You have two ways of doing this. You can expand that pair of brackets and the coefficient in front, but I think it's more interesting to just factor this trinomial, practice our skills. So I'm going to take out the GCF first. X squared plus 4x minus, now 3 into 288 is equal to 96. And then we kind of have it given to us because it's telling you in the answer that it's going to be x plus 12 and x minus 8. So now it's just a matter of checking. Is the 12 times the negative 8 going to give you 96? Is the x times the x squared going to give you the x times the x going to give the x squared? And is the 12x and the negative x going to give you the positive 4x? So it works. Something that you're going to learn later on math, QED, quod erat demonstratum, that which has been proven. Got a little bit of Latin for you. And that's the end of it. Hopefully this helps a little bit, and you'll get a question similar to something like this on the test.